Hello everyone, this is our class number 18, Multiple Regression Model Asymptotics. This is chapter 5 and we're going to cover chapter 5 in one class. It's relatively a short one and the idea is very basic and simple. Okay, so if this is the first time that you're seeing the term asymptotic, I want you to think about the asymptotic as large samples, right? We're going to look at the properties of the beta hats and when the sample size is large, right? Now, as of now, we didn't say anything about the sample size. Well, the data set that you work with in the Woolridge, so for instance, the sample size was 10, sample size was 100, sample size was 300, and etc., right? We didn't have the luxury to increase the sample size, and we didn't study the properties of the beta hats when the sample size increases. We were given a fixed number, and we work with that. In this chapter, however, we're going to see that's what will happen if you do have the luxury to increase the sample size. Let's say the original model that you're working has a sample size of 200. What if you could increase that 200 to 1,000? What if you go from 1,000 to 1 million, and etc.? Okay, things like that. We will talk about something which is called consistency of an estimator. And basically the idea is that if the sample size gets larger and larger and larger, an estimator is going to be consistent if the distribution of that estimator, let's say beta hat j, is going to get smaller, smaller, and smaller. And eventually, when you have the population, there's no distribution for beta hat j, right? You see the beta hat j in the entire population, which is one number. Okay, we're going to talk about the details of consistency and the definitions in very more detail. But what I want you to take away from this motivation for chapter 5 is, if the sample size is large enough, if I send this n to infinity, or in general, if the sample size is large enough, we can get around a couple of the assumptions that we have already made. You know, we work with 6 assumptions. We call them classical linear model assumptions, and we said that we need them to come up with, ceteris paribus interpretations, come up with hypothesis testing, come up with confidence intervals and things like that. However, in this chapter, we're going to relax assumption number 6 completely, and we're going to drop it out, and we're going to work with a weaker version of assumption number 4 as well. Again, the details are going to be discussed in the next video when I go over the 6 assumptions from scratch. Okay, so with that, I'll see you in the next one.